and I don't know if you had a chance to look, but I'm trying to set up this sort of social tech. So you must be familiar with forking a repository on GitHub.
I know that people do it all the time. I don't myself use any remote repositories. I'm very skeptical of their being there tomorrow.
But the point is that Git, so you can, there's a peer-to-peer system. Git is a peer-to-peer system. So the GitHub version of your repository and your version of your repository are equal. There's a time when the Linux server repository, the Linux repository server was compromised by something or the other. And they simply switched over to using the one on GitHub, and it's all the same. You're just pushing to a different place. But Git is a peer-to-peer distributed file system. Do you use Git at all?
Not for my own files. I routinely fetch stuff from Git repositories for various software projects. What I've needed is revision control for me alone. And so RCS is by far the simplest of these systems. 4 commands does the job, and I've been using it for nigh on 40 years, 30 years. Everything I write is in an RCS repository.
Okay. Yeah, it gets quite interesting. I think it's also widely used, but I think it's used too narrowly. I think there's a lot of other things that could be done with it. But Git is a great social tool.
Yeah, one thing that worries me is you have people contributing to these online repositories, and they'll send out an email message saying, well, if you grab this particular branch, you'll have my recent changes. And I think one ends up with a very ephemeral view of what exactly is this piece of software. There's many different versions of it, and you're never quite clear what anyone was running at a given time.
On the other side of it, every Git commit has a secure hash, and it's computationally impossible to forge that secure hash, in the sense that if two things have the same fingerprint, the same secure hash, then they're the same.
Right. I don't have an issue with that. The issue is just that in a big software project, and I think if you go back to IBM System 360, the operating system design that Fred wrote about, the Mythical Man Month, it was really critical for them to have a chief architect or a small team of chief architects. We have a similar thing in the Linux world where Linus Torvalds is the chief architect of the kernel. And that person really has the responsibility of following everything that's going on and making sure that nothing creeps in that damages the system or hurts its extensibility or growth. And as software projects get big, if you take compilers like GCC and C-Lang now, they're of the order of 10 million lines of code. It becomes very difficult for anyone to have an overview of what's happening. And I worry that is ultimately harmful, because the systems grow beyond anybody's capacity to understand them. And so things are done in them, but not necessarily things that are the correct way of doing things. And so for that reason, I've tended to work on projects that even if they run to many tens of thousands of lines of code that I've written, I still have a mental overview of what's going on.
In the mathematical world, there are these problems that are hard, and some of the hard problems are actually have a very nice feature. So, for example, is a number prime? Well, you can prove it's not prime by producing a factorization.
Exactly.
Now, with some problem, to prove it's prime is computationally hard, and it can be hard to check. I don't know if primes is an example of this, but there are some problems which are computationally hard, but once you've solved them, it's quite cheap to solve, to check that you've got a solution. Factoring is one, but sometimes both sides. So this is what's called a certificate. You solve the problem and then you produce a certificate that you've solved it.
Yeah, the sort of thing that goes on in Bitcoin, bit mining.
Yeah, yeah. And in a certain sense, Bitcoin is a sort of distributed ledger that is in some sense based upon Git, in the sense that it's a series of revisions, and the secure hash guarantees your integrity. So the complexity of software is really an enormous problem, and a lot of good minds have worked on it. It's a shame you weren't able to come the other week, because I see the D of the month as really being the one that you're most at home at. I call it durability, but it could just as well be called archival. And it's so important in so many ways, and it's got that long-term importance, but I think it's also got the short-term importance of, well, here's something I didn't write in my blog, but I think it's actually really important, is there's something called continuous integration that runs on GitHub. So every time you make a commit, at least on some systems, all the tests are run. So you get this continuous integration, and you fail early, you fail often, and you fail early. So if a commit's bad for some reason, you find out. The continuous integration can be set up to do whatever you want, really. And it might simply be to produce a PDF from a TeX source. That's a continuous integration task. You know, your task is to build the software and the PDF documentation. Well, maybe there's no software, maybe it's just a PDF. So set up a Git repository with continuous integration compiling to PDF as part of its behavior. And then you clone the repository, and there you've got a TeX system that somebody can use without having anything. They just write the document into Git through the browser and commit it. That triggers a commit. That creates a commit, so it triggers a build, and the build artifacts are then available for further use for a limited period of time. So if I've got all that right, then you can create something which is thoroughly reproducible. So if somebody makes a mistake, everybody makes this, you know, somebody's document goes wrong, you know exactly the environment in which it was made, and you can reproduce it elsewhere, we hope. And they don't have to install any software at all. And I think that's a fantastic thing for people that need to author documents that conform to strict requirements.
So Jonathan, where is the actual TeX formatting going on? Because if you don't have TeX installed in your local machine, you have a Git repository clone, but all that is just the files for the document you're working on, as opposed to the system that typesets it.
The continuous integration system, you say, usually it runs, well, I think there are multiple ways of the way GitHub does it is that it'll fire up a virtual machine or a container, or fire up a container every time it wants to do something. It will populate the container, and in the as part of the Git repository, there's a recipe for constructing the container. So you say this version of this version of this, you get this stuff from here, and so forth. So it's a reproducible formula. So you have a reproducible formula for populating the container, and then you have a reproducible set of tasks to do once the container is populated, and a reproducible set of tasks to do at the end of it all. So that's in some sense quite similar to what Learn LaTeX and Overleaf does, which is whenever somebody presses the compile button, it goes off, a container or something is instantiated. I expect that everybody now uses containers just because it's so easy to manage and so lightweight. And it does the job. So it's the same thing, but with software development and continuous integration, is part of the commit process. Is what happens when you commit. In version control, you have these commit hooks that say, no, you can't put this file into here because it's got tabs in it, for example. But the commit hooks can do all sorts of things, and Git inherits that sort of stuff. And continuous integration system is another system that does the same sort of thing. That builds the software, compiles the software, runs tests on the software. So I committed a documentation change to something or the other. That's how I recall it. And when I made that commit, the continuation integration ran the whole thing, even though it's only a documentation change. And then in the GitHub workflow, there's this little flag showing saying it passed the continuous integration test. So the software was tested after I committed it and before anybody did anything further. So if you have continuous integration and somebody says, I fixed this problem, and makes a full request, if you've got continuous integration, you will know that the change software satisfies the test because that will have been run automatically. It's the way they do. It's the way these young people do these things now.